This is the third session on reversing diabetes. Today we're going to be talking about fats, putting fats in perspective. ReversingDiabetes.org made this statement: type 2 diabetes is known as a lifestyle disease, sustained by a culture that promotes inactivity and unhealthy food choices, all leading to weight gain and obesity, the leading cause of diabetes. Indeed, 80% of the overweight will develop diabetes. That's profound. My question is there any truth to the claim that we are getting fatter? The CDC produced a series of slides that began back in 1985, where they mapped out the obesity in the United States. I'm going to scroll through this year by year, and we're going to see the progression to see if we really are getting fatter. And please notice the legend across the bottom. The white indicates states where there was no data reported. The blue are showing less than 10% obesity, and the medium blue is showing 10 to 14%. But that legend is going to change. So let's look at it. You'll notice that the light blue states are beginning to turn dark blue, and then something more happens. We're having to add additional legends across the bottom here. What is happening to the light blue states? In fact, they are all gone by 2002. But it doesn't end there. Watch the Mississippi River Valley. We tend to be leading the nation in obesity. And there is actually a correlation that appears between obesity and the rates of diabetes. You'll notice as the obesity increases, so does diabetes. We've captured that in the second slideshow from CDC. You'll see obesity on this side and diabetes on the opposite. Now here we are moving through. You'll notice how much, again, fatter we are, especially in the Mississippi River Valley. But that's only the beginning. Everybody else is following suit. And you'll notice how diabetes is beginning to follow the same pattern, the exact same pattern. They're just about 5 years behind. That's all. So it is a disease that's absolutely ravaging our nation. What are we going to do about it? We have to have done something different in the last 30 years to have made this kind of difference. It's not genetic. It's something that is connected to the lifestyle, what we're eating, what we are doing. So we need to ask that question, and then we need to start exploring what are some of the changes that have happened in our society that could possibly be contributing to this. Well, there were changes, a number of changes that occurred in the food industry in the early 1900s. We had Kellogg's Corn Flakes that introduced prepared breakfast cereals for the first time. Up until that time, if you were going to have a breakfast cereal, it was probably something like oatmeal or cornmeal mush or what have you. But it certainly wasn't something you could pour right out of the box. We began milling wheat into white flour on a large scale. Then there was refrigeration that came along. Now we could store prepared foods for a long period of time. And then also the production of vegetable oils. And as all these changes began to happen, the obesity needle began to move. But it was not a dramatic move until around 1980. Back in the early 1900s, the obesity rate was 1 person for every 150. One obese person, that is somebody with a body mass index of above 30, or in other words, about 30 pounds overweight for a 150-pound person. By 2012, the obesity rate had gone up to where there are 33 persons for every 100 in the population. That's a 48 times increase. You can calculate the change if you want to in percent. That's 4,820% higher than we were back then. Are we getting fatter? The question is a resounding and definite yes. So dietary fats prior to 1910 were primarily what you could get from the animal: butter, fat, tallow, and lard. But around in the 1890s, Procter & Gamble began producing ivory soap. And for this, they used a byproduct of the cotton milling process. It was cottonseed oil. But they purchased a patent in 1909 that allowed them to change the nature of that oil into something that was firmer, more solid, more like tallow or lard. And it would change the cottonseed oil into a solid fat now. And they began selling this solid fat about 2 years later as Crisco. Crisco, the Procter & Gamble began one of the most aggressive marketing campaigns at that time that had been undertaken to that time in order to get housewives to use Crisco, and they simply wouldn't do it because it wasn't considered healthful. They actually gave away thousands and thousands of 2.5-pound tubs of Crisco that these people could use for free to get them using it. They put out recipe books, etc., and it didn't really receive a widespread use until World War II, when people were looking for an inexpensive way to have the fats that they needed. And fats were in short supply. So they turned to Crisco and got used to using it. They began using soy oil for the basis of some of these products. In the 1930s, we were importing soybeans for the protein that were in the soybeans, and fats were a byproduct of that. The problem with soy oil, it's very unstable at room temperature. It becomes rancid. So if you hydrogenate it, then you can leave it sitting on the shelf for an extended period of time, and it will do fine. Around in the 1940s, they linked trans fats, or these hydrogenated fats, they linked them to cancer for the first time in medical literature. And even though some of the scientists were crying out loudly against it, the marketing campaign was still in full force, and the use continued unabated for a number more years. Hydrogenated fats steadily increased in use until the 1960s, and its use was even encouraged by many health officials. However, the tide began to change as people began to learn more about the deleterious effects of these, and by the 1990s, public outcry finally led to mandatory labeling of trans fats. In 1994, it was estimated that trans fats caused over 20,000 deaths annually just from coronary heart disease alone. So the pressure was on. In 2007, because of mandatory labeling, Crisco finally reformulated its fats. Now the government said that in order to have 0 trans fats on the label, that they would have to have no more than 1 gram per tablespoon of trans fats, or it could not be any more than ½ a gram per serving. And so they made their serving size 1 tablespoon. They superhydrogenated their fats. They mixed them with oils until they could get it down to those levels, and they marketed it then as 0 trans fats. But it's still partially hydrogenated vegetable shortening. It still has the deleterious effects, and we're throwing it into all kinds of our food and doing it very happily. That extends far beyond Crisco. That goes to many of the margarines that we use out there. You look at any ingredient list on your processed foods from the grocery store, if it says partially hydrogenated vegetable oil, it is a trans fat, even if it is less than the government rating, and the front of the box might say 0 trans fats. So that's how they get by with it. Anyway, other things that are contributing to our diabetes growth: would include less activity at work. Now this graph shows from 1960 to 2010 alone, but you'll notice how the trends are going, and these have been going for quite some time. Instead of having to do heavy duty at work, most of our jobs fall in the moderate to sedentary to the light physical activity at work, and we have been increasing those jobs which require light and sedentary activity, and we've been steadily decreasing those that require harder labor. That's because of increased mechanization and all sorts of other things, and you might call it progress, and on the one hand it is, but on the second hand it has definitely played a role in our diabetes epidemic. Increased inactivity at home is another thing. We're finding more things to do with our leisure time, and if you'll notice in this legend, the purple again represents predominantly what you're going to see over here somewhere near the Mississippi River Valley, but we're all headed that direction. If we're wise, everybody will move to Colorado or Idaho, I guess. Then we'll live in an area where people tend to be more active, and it'll be the easier thing to do. Don't get all excited. Their map is shading badly as well. Screen time. Since 1950, screen time has been continuously increasing. My chart here goes up to 2000, but I understand from some of the latest data going into 2010, it's still increasing. When I talk about screen time, I'm talking about television viewing, time in front of the computer, texting, etc., cell phones, etc. So, what are we doing in our leisure activity? Well, in the course of a week, the average person plays 13 hours of video games a week. And they spend 17 hours of time online looking at the computer. And they spend 17 hours texting, 28 hours watching TV, and less than 2 hours a week doing any kind of physical activity in leisure time. Folks, that's right around 15 minutes a day. That is a sad litany. So is it any wonder that we are increasing on the diabetes area? Then we have an increased intake of calories. Looking from 1970 to 2010, you'll notice a chart here in the United States shows that we have increased our caloric intake by about 700 calories per person per day over that time period. And then when you break it down and ask the question, what is it that we are eating? We have the 3 years, 1970, 90, and 2008 here, and you can see that in 2008, we're eating approximately 200 calories more flour and cereal than we ate in 1970, and we're eating another over 200 calories in added fats and oils. I might subject to you that the reasons for that are because we are eating so many more processed foods than we did. We used to, over 90% of our workforce in the year 1900 was involved in agriculture. Today, we're at it's less than 1%. It's less than 1% today that works in agriculture. So we are eating more, and then we have the increased intake of high fructose corn syrup. And it was around 1980 that Monsanto Corporation came along with a brilliant marketing plan and began marketing high fructose corn syrup to a large degree. And the diabetes epidemic taking off sort of mirrors this kind of waveform right here. And it's interesting to note that in 1954, the U.S. government actually outlawed the use of high fructose corn syrup in cattle feed because it gave the cattle diabetes. Interesting. And then just a few years later, we add it to our human consumption and expect nothing to happen. So let's go back to the cell. When we feed all the cell this glucose, the cell takes that and it burns these carbohydrates for energy. And actually the cell favors carbohydrates. So if you're feeding it sugar, starches, high fructose corn syrup, etc., those things are going to be burned up before it works on fats and proteins as a form of energy. So the cell then takes the excess of whatever it doesn't burn up, stores that as fat in the reserves. Now, Let's think a little bit about fat. With diabetics, one of the first things we tell them is you can't have carbs. And is it true that carbs will spike your blood sugar? Well, yes, it's true. What do we feed people in place of carbs? If you take some food away, then you're adding some food back, are you not? Well, what we typically add back is we add proteins and fats. And I want you to notice right here, caloric content. Carbohydrates contain 4 calories per gram. Proteins contain 4 calories per gram. But when we move into the fat arena, it contains 9 calories per gram. So as we develop diabetes and we make this switch, now we're eating foods that are even more dense calorically, thinking that we are being healthful to ourselves when in fact we may not be. Now, fat is about 2¼ times more concentrated than either your protein or your carbohydrate. So I like to liken it to a woman who goes to the grocery store and she buys a can of frozen condensed orange juice. Now, typically you'll take that can home, you open up your pitcher, you dump the can of concentrate in, and then you add 3 cans of water to it. That's almost the same concentration as what we have right here. So, fat is digested a little bit differently from your carbohydrates and your fats. That's why it makes a difference in your bloodstream. So you think about how it's absorbed. The fat, when it's absorbed, comes, it's broken down by bile into small little fat particles, and it's absorbed through the intestinal wall into the bloodstream. And if you eat canola oil, it's absorbed as canola oil. If you eat chicken fat, it's absorbed as chicken fat. If it's lard, it's absorbed as lard. It comes across in its form. It's not broken down or reassembled. It actually requires less energy to get that into the body than it does when you eat carbohydrates or proteins. Now, what happens with carbohydrates or proteins? With carbohydrates, it goes down into your stomach through the digestion process. It's broken down into simple sugars, and then it's brought across into the body, and when the body can't use those sugars, then it's reassembled into triglycerides, or the body reassembles it into what it wants it to be, and then deals with it that way. So there's energy on both sides, energy spent breaking it down, there's energy spent reassembling it. With a protein, you take a protein into the body. That protein, unless it's a protein that's in mother's milk, that protein comes into your body, is broken down into constituent amino acids, then it moves across into the bloodstream where it's reassembled into proteins on the body, within our body, that the body needs to have in order to meet its requirements for growth or cellular health. So there's also energy used there to break down the fat, the proteins on both sides, on the one side, and then to reassemble it on the other. That all takes energy. So, but fat, when you absorb fat, it does not require insulin because it forces its way through the wall, and then when it moves into the cell, there's no insulin that has to come along and open up any doorway. It just pushes its way into the cell and sets up housekeeping there. And so ultimately, it becomes the fat that gums up the locks and the cells that we talked about in the previous lecture. The fats in the cell, we have a name for it. We call it intramyocellular lipid. Intra means inside. Myo means cell. Myo means muscle, and cell is the cell. So intramyocellular lipid means the fat that is inside the muscle cells. And that's what ultimately will gum up the locks. Of course, high levels of fat, we learned in the previous lecture, actually cause inflammation, and the inflammation sets up a bad cycle. We'll talk about that in an upcoming lecture as well. It's interesting that in 2004, Yale University did a study where they discovered when this fat in the muscle cells becomes 80% more than normal, then that's when you develop symptoms of diabetes. And that is the intramyocellular lipid that I was talking about. In addition to that, we have recent research that was just came out in 2011 from Newcastle University in England that I think is very exciting. And in this research at their magnetic resonance center, they did some very detailed, very well set up research studying diabetes and its progression. And they determined the mechanism they feel by which diabetes occurs, and it occurs through an accumulation of excess fat. And they specifically targeted fat in the pancreas and fat in the liver. If your doctor's told you you have a fatty liver, you can rest assured you're probably well on your way to getting diabetes, and it's time for a wake-up call. The Newcastle Center determined that there are different levels of fat tolerance, and at this point in time we don't have the science to be able to predict what level of fat you may have. For instance, you may be a person that is very slender in your build. You might have a fat threshold with a body mass index of, say, 19. That's really a fairly lean person. But if that's your normal and that's your threshold, and you go to 21 on your BMI, then you come down with diabetes, whereas your friend right next door might have a threshold of 45. And it's not until they get 48 or 50 that they're going to develop the symptoms of diabetes. So it's actually different for everybody. At this point in time, we don't know how to predict what that amount is. But we do know that weight loss is imperative if you're going to reverse your diabetes. So they discovered also that in some of these diabetic patients that they were studying, that they would get them, they may be able to get blood sugars to normalize within 1 week on an extremely strict diet, which they don't recommend for the public, and neither do I. But then it would take an additional 6 weeks on this extremely rigid diet, and they would actually normalize beta cell function. Now that is a new day in diabetes research, because up to this time we have said diabetes is an irreversible disease. But the Newcastle research seems to be flying in the face of that, where they have substantiated that actually beta cell function will return to normal if you allow those cells time to rest and heal. And so that is what we're seeing clinically in some of the things that we're doing here in this program. So one of the things they did, they took 77 people and had them report how much weight was required to reverse, and the average weight loss was 32.5 pounds, and the reversal rate they discovered was actually related to two factors. On the one hand, weight loss, and the other one, how long a person had had diabetes. If you've had diabetes less than 2 years, then at that kind of weight loss, about 80% of the people, I believe it is, will be able to reverse their diabetes, and others may have to wait longer. Yet again, there are some factors there. Theoretically, it is possible for everybody to reverse. There's lots of hope out here, which we have not had until recent years. So, high fat in the diet actually causes changes within your body for 3 to 6 hours after the meal. It causes inflammation in the arteries, and it causes something that we call blood sludge. The blood gets sticky and it doesn't move through the capillaries very well. This causes it to decrease the immune response. And Seth talked about immune response in a previous lecture. It also increases your risk of cardiovascular disease because of all this inflammation. Any type of fat in high quantity causes an increase in insulin resistance. So it's very dangerous to go to a diet that's high in fat in order to just control your blood sugar. A high blood sugar in diabetes is not the problem. The problem is insulin resistance. The high blood sugar is simply a symptom of the underlying problem that you have. So we believe that moderate intake of good fats is healthful. We'll help you define what is good and what we consider bad in the near future. The body preferentially burns carbohydrates and it stores the fat. That's a take-home message. So if we're eating lots of fat, that fat's going to be stored on the hips and we're going to burn the carbohydrates. So if you have to err on a side of anything, the intelligent thing to err on the side of, in my thinking, is to err on the side of consuming too many carbohydrates rather than the side of consuming too many fats. Okay, let's look at the bad fats now. I call the bad fats the saturated fats and the trans fats. Now, saturated fats are those fats that are hard already. They are solid at room temperature. They come from animal sources. All of them cause inflammation. They all worsen cardiovascular disease, and they all increase insulin resistance. So those are the kind of fats that we want to try to avoid when we are trying to reverse diabetes. Now, in the standard American diet, what do if we're trying to manage our diabetes? We get away from the carbs and we try to move to the proteins, but the proteins, most of them that we in our way of thinking, most of those come from the animal products. And when you have animal products, your meats, even the lean meat, take lean meat, it's 90% lean and it's 10% fat if you're getting ground beef. But when you actually look at the constituency of what that lean meat is made up of, if you measure it by calories, the percentage calorie is over 48% calories. So you're still getting a lot of calories, and all that, you remember, is stored, while carbohydrates are used preferentially, and then it'll move to proteins and fats after that. So anyway, and you might say, well, I'll go to the extra lean. The extra lean, well, that's 5% fat, and that's a better choice, but it's still 33.3% fat. So be careful about your extra lean ground beef. That's not where it's at. There are other foods which are better. We will zero in on those on a later lecture. Trans fats are those fats that were liquid in their original form, came from plant sources, and now have been made solid at room temperature by the hydrogenation process. These cause inflammation. They raise the bad cholesterol. They lower the good cholesterol. They increase the risk of heart disease and stroke, and they also increase insulin resistance. So fats, some fats are healthful in small quantities, and I would say the emphasis is probably on the small, and these would be some of the fats like polyunsaturated fats, corn oil, cottonseed oil, peanut oil, soy oil, sunflower, the vegetable oils. Those are the ones that we're talking about here for the most part. There are also some healthful type fats in some of your deep sea fish like mackerel, salmon, and cod. And some of these fats will make fairly good replacements for the saturated fats that you've been eating. But a word of caution, when you go through the salad bar, it's best not to have salad on your dressing. You want dressing on your salad. And lots of helpful strategies can work out. Maybe one of the things you could try is get your salad dressing on the side. Simply dip the tines of the fork in your salad, in your dressing, and then in your salad you get some of the flavor. You'll only eat a fraction of the amount of oil. There's lots of ways, tips of things that we can do to reduce our intake. And we will be telling you in the future of ways that you can actually make substitutions in your recipes and cut out some of the fats of foods that you commonly eat. Fat is a refined food product, and it requires additional nutrients to metabolize it. It's a lot like eating refined sugar. It requires additional nutrients to metabolize it, and when we don't take those nutrients in, when we're taking in this refined food product, then what we're actually doing is we're causing ourselves to be in a situation of cellular malnutrition. We don't want that. And then finally we come down to the class of fats that are called monounsaturated fats. And these are the more healthful fats. But again, remember that any amount of fat, any fats consumed in large quantities increases insulin resistance. So it's not good enough just to substitute olive oil or canola oil or safflower or peanut in place of some of the more firm fats when you're doing your frying or other food preparation. We need to reduce our total fat intake. And these good fats do improve blood cholesterol, and they're possible benefits for the diabetic if they're eaten in moderation. And again, remember that a fat is a refined food product. It's best if you eat it in the natural state. And we will talk a lot about whole food. And the whole foods, the reason why we emphasize the whole foods is because packaged within the whole foods, nature has placed all of those elements that are required to properly metabolize those without making your cells malnourished. So the requirements, the actual requirements for fat are very small. In the standard American diet, we eat about 35 to 37% fat. And most vegetables and fruits are very low in fat in the range of around 10%. So I would encourage you to make your fat intake come primarily from nuts, seeds, avocados, olives, and things of that nature. And let's stop eating all these refined oils on our foods. I have a chart here. I'm sorry it's not clearer on the screen, but we have compared here a number of various countries, and it's the percent fat and carbohydrate that each of these countries eat. And the United States is right over here. We have the highest fat intake. And as the fats decrease, you'll notice that the people typically increase their carbohydrate intake. And as carbohydrate intake goes up, the rate of diabetes goes down. Now, we've given carbohydrates a bad rap for a long time. And I would subject to you that the problem is not carbohydrates. The problem is twofold. Number one, the amount of fats that we consume. And number two, the amount of refining that we do to the carbohydrates to make them poor for our health. So what we need to do is we need to change the type of carbohydrates that we're taking in. Instead of doing those that make us sick, let's do the whole food that has all these nutrients that help us metabolize it. And when we do, then the body starts doing its natural thing of causing you to lose weight, and the weight will just drop off until you get back down to a new normal body weight for you. It's amazing to watch this happen. Now let's talk about inflammation. There's a strong correlation between obesity and inflammation. And some people have said, some of the researchers have told us, that they think that this is the single most important factor driving the diabetes epidemic. So we need to get inflammatory processes down. Lots of ways to do that. But it begins in the fat cells. The fat cells will, when you become diabetic, they actually alter the way that they metabolize things. And they, all the cells of your body will begin pumping out all kinds of things that we call dangerous chemicals, we call reactive oxygen species or free radicals. We're going to talk about those in another lecture. But we want, these cause a lot of inflammation in the fat tissues. It causes insulin resistance. It causes inflammation in the brain and causes leptin resistance. So there are many inflammation-causing substances in our environment, which include cigarette smoking. If you're a cigarette smoker and a diabetic, this is one of the first things you can do to begin reversing your diabetes, is to stop smoking. One of the most difficult things you will ever do, because nicotine is probably the most addictive substance known to mankind. Then you'll also want to do your best to decrease environmental pollutants, pesticides, chemicals around the house, etc. Air pollution. Get out in the country and enjoy the beauty of nature and clean air. Install air filters if that isn't the problem. And then get rid of inflammatory foods. Those that are high in refined sugars, those that are highly refined grains, processed foods of almost any kind. Do your shopping in the grocery store, around the outside in the produce section. Saturated fats and trans fats, try to cut those back to an absolute minimum or cut them out altogether. And then superheated oils, that would be fried foods and meats, animal products. These are all things which are going to lead you down the path to inflammation. Dr. Joel Fuhrman put together a formula which I think is absolutely profound. And that's H equals N over C, where your future health equals nutrients over calories. The more of the vitamins, minerals, the phytonutrients, etc., that are in your diet in relation to the percentage of calories that you eat, the higher that number becomes. But when you're eating highly processed foods, the number on the top becomes very low, and the number on the bottom becomes very large, and your health takes a nosedive. So we are going to be talking about how to apply that. And one of the first ways we apply that is this food classification list. This was developed by Dr. Wes Youngberg. He took Dr. Fuhrman's formula and he studied foods and he grouped them into classes and he tested the amount of, he measured the amount of nutrients in these food classes, collected an immense amount of data and put it together in a hierarchy of foods that he calls first-class foods, second-class foods, and third-class foods. And as you move through this hierarchy, the higher you go up the list, the more inflammation reducing the food intake is going to be. The further down the list you go, then the more inflammatory those foods are going to be. The higher you go up the list, the more healing you're going to have. The lower you go down the list, the closer you're going to be to putting yourself in a state of ill health because you're creating inflammation in the body. Now this food list you can get from a variety of sources. You can get it by getting Dr. Wes Youngberg's book, Goodbye Diabetes. It's printed in there, or you can get it with the packet that comes with this DVD set. There are a number of benefits of eating healing foods. You reverse all kinds of inflammatory diseases. And it's not just your diabetes that'll go away. Many of our people, their doctors will start cutting back on their blood pressure medications. They cut back on their depression medications. They cut back on pain medications, etc. Dr. Colin Campbell, T. Colin Campbell, says that there are several categories of foods that are available. The most important being the antioxidants, because it's those antioxidants that deal with the inflammation. These are only made by plants. They only come from plant sources, and you find almost none of those components in any of the animal products, whether it's dairy, chicken, fish, red meats, etc. Then second, most important, are your complex carbohydrates. When you're eating a whole foods diet, you're getting that whole apple as opposed to the apple juice. Well, for instance, think about it for a minute. One apple, one medium apple is a pretty good serving, or 1 4-ounce glass of juice. You'll take 6 to 8 apples to make the glass of juice. So you get all those calories in that glass, and you leave all the fiber behind. When you eat the apple, you have the fiber, you have the nutrients that are in the peel. Those nutrients in the peel actually are some of the chemicals, the phytonutrients, that actually will help reverse your disease process. So the whole food is packaged with a lot of things that help you heal. Anyway, the complex carbohydrates are those that are found in the natural whole foods, things like whole grains, beans, etc. These are only made by plants, and you will find none of those in your animal products. But the animals get their nutrients from this source. Then you have vitamins. Again, they're only made by plants and almost none in the animal sources. Then you have fats. In a plant-based vegetable type diet, you have 9 to 11% fat. And of protein, you'll have 9 to 11% protein. Plenty of protein, plenty of fat for all our body needs. And then in the animal sources, they are a little higher. So, question is, what do you want to do to your health? Well, Socrates said, let thy food be thy medicine. And T. Colin Campbell said that 75% of disease is preventable with diet alone. Well, that's profound. And I want to put myself on a path where I am able to prevent 75% of future diseases that come my way. And I also recognize that with good health comes enjoyment of life. I hope you can enjoy the same level of health in your life. So take a few minutes now and write down what your health goals are. Remember to make them specific, make them measurable, make them attainable, realistic, and time-bound.